All right, evaluating expressions and functions basically means that you're going to plug in the values that they tell you. For example, in this first one, it says f of 1. That tells me to go to this f function, and where that x is, you can see that they replaced it with the number 1. So you're just going to, in your mind or on your calculator, which is what most people do just because it's the fastest and you want to save time, open a parentheses, say 4 times 1 plus 3, close the parentheses, squared. That's 7 squared, which is 49, or K. On the second one, this is one where there's a careful mistake that we got to make sure that you don't do. This time it's telling us to put a -3. Every place there's an X. So I'm going to say 2, and this is the place where students make mistakes. It's -3 in the parentheses squared plus 6 times -3 minus 7. You must use these parentheses or you'll get it wrong. So if I type that in the calculator, I'm going to get B, which is -7. Now this next one is interesting. It's what we call a piecewise function. It's a function that's defined in pieces, and otherwise it means one thing. For example, it means this if x is less than 4. But it means this if x is greater than or equal to 4. So in this particular question, it's telling us to find f of 4. So then what you have to do is you have to decide, because f is 4, am I going to use this top yellow formula that I use if x is less than 4, or am I going to plug into the bottom green formula if x is greater than or equal to 4? Since I am 4, I'm going to use that bottom equation, and I'm going to put a 4 right there. So I'm going to say -1/2 times 4 minus 3 and get f, or -5. Right? The next one. Here's one where you're just doing the same thing, but you're just plugging in various variables. Wherever you see the x, put in a 5. Wherever you see y, put in your 3s. Wherever you see z, put in a -6. And watch out because it's minus a -6. So minus a -6, and then you're going to have plus -6. You're going to put that in your calculator or do that quickly in your mind, and you're going to get A, which is -42. I do want to caution you to be very careful about this minus a negative. All right, this next one, we're going to do the same thing. We're going to plug our values in. It says 5, but where the x is, we're going to put -2. And if you would prefer just to say times -2, that's fine. But on this next one, when you have the exponent, you must use the parentheses when it's an exponent, especially with a negative. And so I'm going to type that in the calculator, and when I do so, I get B, or -160. Here's another type where they're kind of doing this as an ordered pair, but it's the same thing. It's telling me x, y. So for x, I put in a 3. For y, I put in a 2. So again, mind or calculator, you're going to say 3, but where the x is, I'm going to put in a 3 squared minus 4 times 2. And I just a lot of times will say times 2, but you could certainly do it that way. It's just personal preference. You'll get the same answer, which is C. All right, here's an evaluate expressions as a word problem, which is good because you see these quite often. It says the number of fish, F, so F is the number of fish as far as plugging in variables, in Skipper's Pond at the beginning of each year can be modeled by the equation right here. where X represents the number of years since or after the beginning of 2000. That's what our variable is going to be. So it's the number of years after the year 2000. For example, X equals 0 would be the year 2000. 1 represents 2001, and so on and so on. So according to this model, how many fish would be in the pond at the beginning of year 2006? So hopefully, seeing that 0 represents to 2000, 1 represents to 2001, well then 2006 would represent if X were equal to 6. So just go back up to your equation and say 3, open your parentheses, 2, use your exponent button on the calculator to the 6, put that in there, and you're going to get B, which is 192. Here's another word problem. Let's look at this one. You've got this score, this standard score Z, corresponding to this raw score X, and it gives me a formula right here. And then what it's going to do is it's going to tell me in the problem what everything stands for. This variable is 78. I'll put it in for that one. This variable is 6. I'll put it in for this. Z is 2. I'll put it in where Z lives. But I want to solve for X. So let's go right back up here to the formula and let every variable go live in their house. So where the Z is, I put a 2. Equals, where the X is, that's the, I don't know. That's what I want to know. So put in, just leave it X, minus, where this variable is, we're going to put in a 78. All over, where this variable is, we're going to put in a 6. And now we just have an equation where we solve it for X. When you have an equation, I don't like that fraction probably any more than you do, so let's clear it out. So if that's a divide by 6, let's just multiply both sides by 6. That way, the 6 in the top and the 6 in the bottom cancel. 6 times 2 is 12 equals X minus 78. Now, add your 78 over, and so X is equal to 90, which is letter F. All right, last one, and this is question 50. It's still evaluating functions, but in the form of a graph, so don't let this throw you off up here. We just want to know what is F of 5a. That means we're going to put a 5a for X. So let's just walk along this axis where 5a would be, and it would be right there. If that's 4a, there's 5a and 6a. So I'm going to go to 5a, and I'm just going to trace it up. Just keep following it all the way to the picture right there. Notice that your answers here, you're going to come across and see that it's 8b, which is K, 8b. I hope you found this video helpful and found lots of examples showing you how you could use to evaluate expressions on the ACT. If you found this video helpful, be sure to check out some of the other ACT prep content videos. See you later.